Hey, fourth graders, Mr. Height, your favorite scientist, back at you. Whoa, we got some cars on track here. Lightning McQueen, everybody, big race. So welcome back, and today we're gonna set up our experiment. So we are gonna do a little experiment um, using some very simple materials, but just to help us understand speed and position, motion, and velocity, acceleration, all those things having to do with how objects can change motion. So first of all, we want to start out by actually setting up our experiment. And we do have a page for that you can use, or you can use your science notebook, but we do have this available for you to use. So our experimental question, what we're trying to find out is, how does increasing the height of the ramp affect the speed of a marble? So a little different here is each group is going to actually do the experiment, but using the independent variables. So think about this. In the question, it already has our independent variable, the thing that we're changing. What are we changing to see what's going to happen to the speed of the marble? So you should say, well, we're going to increase the height of the ramp. So that's exactly what we're going to do. That's our independent variable, because we want to see if we increase this ramp height, what's going to happen to the speed? Is the speed going to increase, decrease, or stay the same? So that's what you would write in here for the independent variable, is that you will change the height of the ramp, and you can actually put in specific numbers. So each small group is going to get a certain number of books. So I'm going to use a science source. So you can use science source or whatever books you have. So group 1 will have 1 book, group 2 will have 2 books, and so forth, all the way to, if you have group 6, they would have 6 books. And the cool thing is you can use a ruler to actually measure how tall that ramp is going to be. So for example, if I measure my 1 science source book, it measures about 1.5 centimeters high. So you can even write some more of that information. So if you're group 1, you're saying, hey, I'm changing the height of the ramp, and we are going to use 1 book, and your 1 book is, if it's a science source, could be 1.5 centimeters. Group 2 will have 2 books. So the cool thing is every group is going to independently record their height, and then you guys will bring all that data together to talk about what happened. So that's kind of cool. Is usually one particular group will do all 6, but this will be a lot faster if one group does 1 book, group 2 does 2 books, group 3, yada yada. Okay, so that's the one thing we're changing. We're going to see what happens as that ramp height gets higher. What's going to happen to the speed of the marble? Dependent variable, this is what we're measuring, okay, in the experimental question. And don't get confused, oh, we're measuring the height of the ramp. No, that's what we're changing. We're going to change the height of the ramp. What's going to be the effect of that? So what's going to happen? So what would our what would our dependent variable be? Again, it's in the question. So hopefully you said the speed of the marble. That is what we want to measure, okay? And how do we measure that? So how do we actually find the speed of the marble? Well, you need 2 things. You need distance, so we can use a tape measure to measure the distance the marble travels. So there'll be 2 things in this one actually. To get the speed, we need 2 things. We need the distance, and hopefully you also said time. We need the time. So distance and time in order to calculate the speed. And it's always good to put what tools you're going to use. So if you're going to use a measuring tape in centimeters, and use a stopwatch and measure in seconds, and then calculate the speed, which is distance divided by time, which is very cool. So that's what you would put for dependent variable. Coming down here, so if this is our question, how how does increasing the height of the ramp affect the speed of a marble? This is going to be very interesting because each group is going to have to be very careful how they set this up. If group 1 sets up their book, but possibly uses a different marble, maybe a marble that's heavier or lighter, would that mess up the data? Would it be reliable data? Probably not if I used a plastic marble versus a metal or a glass marble. So that's something that needs to stay the same. Each group should have the same mass of marble, and you could totally measure that. You can use a scale to measure that. So that would be one thing that would stay constant. Also, the length of the ruler. So if you're going to use a ruler, make sure you have the same length rulers. You might even, here's a plastic ruler with a groove, and also have a wooden ruler with a groove. Could that make a difference? Especially if one is longer than the other. So you want to make sure that is also consistent. Like I said before, I would use the same books for each group. So if I would use all science source, I know each science source is about 1.5 centimeters tall. So that would help out greatly. What would be some other constants you'd have to make sure? What about the surface? So if I roll the marble from the ramp onto a table, how is that going to be different if I roll it onto carpet? So wouldn't we have to make sure the surface is the same? Okay. So that would be another huge constant. And each group, if they follow these rules, your data will come out really nice. You won't have data that's all over the place. Because in an experiment, we only change one variable. And remember, the one thing here we're changing is increasing the height of the ramp. So we got to keep everything else constant. Okay. Those are some of the constants I thought of. Can you think of any other constants that could be important? If you can, go ahead and write those down. Okay. And then finally, let's make a prediction. So these are some of the outcomes that could happen. And we want you to think about which outcome you think is most likely going to occur, and circle that, and also put your thinking. So the first thing that could happen is increasing the height of the ramp will increase the speed of the marble. So if I look at group 1 with 1 book, and then I look at group 6 with 6 books, did the speed actually increase? Okay, that's what you guys would look at. That's the cool thing, is you'll bring all your data together. The second thing that could happen, increasing the height of the ramp will decrease the speed of the marble. Okay, so you'll look at all your data together, look at group 1 through group 6. Did it actually slow down? Okay. The last thing that can happen is increasing the height of the ramp will result in no change of the speed of the marble. Maybe group 1 with 1 book, their marble went the same speed as group 2, group 3, group 4, group 5, group 6. And what I mean by that is not like 1. Sometimes students think, well, if it's off by 1, it means it did change. Very little, like a change in temperature. So if it's 85 degrees and I get 86 degrees, is that really much of a change? Not really. But if I get 85 degrees and I get 105 degrees, is that a big change? Yes. So if it's off by 1 or so, it's not really changing. So you really want to look at the trends. So it could happen where it didn't affect the ramp height didn't affect anything. It just kept going the same speed, no matter what. That could happen. I've seen that happen in experiments. What do you think is going to happen? So you're going to circle 1, 2, or 3. And then please, down in the space below, write an explanation. If you chose 1, explain your thinking right here. Why did you choose 1? Or why did you choose 2 or 3? So that is our experiment setup. And again, materials that you will need for our experiment setup is you'll just need a book, a ruler with a groove. You should have some rulers, and you have that little groove in there. A marble. So I got a marble right here. And I have a tape measure. Cool. And I will be back to kind of run through one. As you look at how you're going to set it up, I'll come back and do that for you guys. And I'll even have a little bit of data. So I'll actually do my experiment with one book. And you could also then continue the experiment from there. So good job everybody, and I'll see you next time.